Since the dawn of the automobile, people have craved more power. This desire for speed has driven innovation in engine technology. Forced induction boosts an engine's output by pushing more air into it. The two most common methods are turbochargers and superchargers. Both achieve similar goals but through different means. Understanding their mechanisms helps appreciate the engineering. Turbochargers and superchargers evoke images of high-performance vehicles. Their applications extend to various vehicle types, including everyday cars. Forced induction can also improve fuel efficiency and reduce emissions. Exploring turbochargers and superchargers offers a glimpse into automotive performance. The quest for increased engine power has led to remarkable advancements. Turbochargers and superchargers are prime examples of engineering ingenuity. We'll uncover the secrets behind their power-boosting capabilities. The following sections will compare their operating principles and applications. Turbochargers are ingenious devices that harness the energy often wasted in a car's exhaust system. Imagine capturing the force of rushing exhaust gases and using it to force-feed your engine with even more power. That's essentially what a turbocharger does. It's a system that seems almost magical in its ability to transform wasted energy into exhilarating performance. At the heart of a turbocharger lies a turbine and a compressor, connected by a shaft. This assembly is strategically positioned in the exhaust stream, where hot gases exiting the engine cylinders spin the turbine at incredible speeds, often exceeding 100,000 revolutions per minute. This rapid rotation, in turn, drives the compressor, which acts like a powerful fan, drawing in ambient air and compressing it before forcing it into the engine's intake manifold. This process of compressing the intake air is crucial. By squeezing more air into the cylinders, the engine can also burn more fuel with each cycle. This increased air-fuel mixture translates directly into a significant boost in power output. It's like giving your engine a shot of adrenaline, allowing it to perform at a level far beyond its natural aspiration. However, this power boost doesn't come without its quirks. One of the most noticeable characteristics of a turbocharged engine is the phenomenon known as turbo lag. This refers to the slight delay between pressing the accelerator pedal and feeling the surge of power from the turbocharger. This lag occurs because it takes a brief moment for the exhaust gases to spin the turbine up to speed and generate sufficient boost pressure. Once the turbo spools up though, hold on tight because the acceleration can be exhilarating. While turbochargers rely on the energy of exhaust gases, superchargers take a more direct approach to forced induction. Imagine a powerful air pump directly connected to your engine's crankshaft, working in sync to provide an instant surge of power. That's the essence of a supercharger, a mechanical marvel that delivers immediate gratification in the realm of automotive performance. Unlike the somewhat indirect method employed by turbochargers, superchargers are mechanically driven by the engine itself. This direct connection, typically via a belt, chain, or gears, ensures that the supercharger spins in direct proportion to engine speed. As the engine revs up, so does the supercharger, compressing air and delivering it to the engine's intake manifold with minimal delay. This direct mechanical link between the engine and the supercharger results in one of its most significant advantages: instant throttle response. Unlike turbochargers, which experience a slight lag as the turbine spools up, superchargers provide an immediate boost in power the moment you hit the accelerator. This makes for a more linear and responsive driving experience, particularly desirable in applications where immediate power delivery is crucial. Superchargers come in various types, each with its unique characteristics and advantages. The most common types include Roots, twin-screw, Lisholm, and centrifugal superchargers. Roots superchargers, known for their characteristic whine, are relatively simple in design and provide a significant boost at low engine speeds. Twin-screw superchargers offer greater efficiency and a more linear power delivery, while centrifugal superchargers, with their resemblance to turbocharger compressors, provide a balance of performance and efficiency across a wider RPM range. When it comes to forced induction, two primary options dominate the conversation: turbochargers and superchargers. Each has its own set of advantages and disadvantages. Turbochargers are driven by exhaust gases, which means they can provide significant power boosts without directly impacting engine efficiency. On the other hand, superchargers are mechanically driven by the engine itself, offering immediate power delivery, but at the cost of some engine efficiency. So, How do you decide which one is right for you? Well, it really depends on your specific needs and driving habits. If you're looking for a quick burst of power for track days or spirited driving, a supercharger might be the way to go. However, if you want a more efficient power increase for daily driving, a turbocharger could be more suitable. It's also important to consider factors like installation complexity, maintenance, and overall cost. Looking ahead, the future of forced induction seems promising. Advances in technology are making both turbochargers and superchargers more efficient and reliable. We're seeing innovations like electric superchargers and more advanced turbo designs that reduce lag and improve performance. As automotive technology continues to evolve, we can expect forced induction systems to become even more integral to high-performance and efficient engines.